All right, in this section, we'll take a look at how to use scalar product to find the angle. All right, find the angle between two vectors. Let's take a look at it. Suppose we have two vectors here, A and B, and suppose we have these two vectors A and B, and we want to find the angle between these two vectors. So this is the angle, and we all know by definition, again, like we covered the earlier section, by definition, A dot B is modulus of A, magnitude of B, cosine theta. We can now make theta, or rather the cosine theta, the subject of the formula. All right, make cosine theta the subject of the formula, meaning to say we divide both sides by the magnitude of A, magnitude of B. Then we actually will get this one. And furthermore, what is A, vector A divided by magnitude of vector A is actually the unit vector of A. Similarly, B divided by magnitude of B is just your unit vector B. So you can use either this one or this one interchangeably. All right, let's take a look at how we're going to use it in an example. So in this example, you are given the position vector. Usually what we would do, as we've done many times, is to rewrite this one as a column vector -1, 2, 1, and this as a column vector 1, -1, 0. It's a lot easier to rewrite it. So sure, you've got position vectors of A and B like that. Find angle AOB. Let's tackle one thing at a time. Let's tackle angle AOB. All right, I've written this in column vector. Let's suppose we draw this diagram. What is AOB? Now, recall what we learned earlier. Okay, recall what we learned earlier. Cosine theta is actually unit vector of A dot unit vector of B. So we are going to use that. Okay, either, like I said, you can use either this or this, and you will get there. Because look here, this important is to draw this arrow and say this is OA, this is OB. All right, so actually it's OA vector. Sorry, I think I better be very clear, and there is an arrow here missing. OA vector and OA vector, OB vector. Okay, and fill them in. It's not difficult. You fill the unit vectors, the column vectors in. Okay, then you put the magnitude in as well. Then you get some numbers. Now, you do take note that there is a negative sign here. Okay, you get a negative sign here, and you do the arc cosine, or some of you call it inverse cosine. You realize that AOB is 150 degrees, which is an obtuse angle, which is fine. Leave it as it is. It actually just means that if you look at my diagram initially, I didn't know what was the angle AOB. But after I find it is an obtuse angle, you realize that actually this diagram is a bit wrong. So I'm going to go to the next slide. It's actually wrong. Why? Because your angle AOB is 150 degrees. Actually, this should be the correct diagram. All right. Would it actually affect our answer for the next part of finding area of AOB? The answer is no. Actually, it wouldn't affect how you could proceed. Because how do you find angle, or rather, how do you find area of triangle? You recall area is half AB sine C. We've got this is the magnitude of A, this is the magnitude of B, and you're going to sine 150 degrees. So whether you draw your diagram like this or like this, it wouldn't make a difference. I will still proceed as per normal. Half mod OA mod OB is sine 150. You will still get the same answer. All right, but sometimes it matters. In this case, it doesn't matter. That's that.